Hey Math 8, here's our first lesson of the year, solving simple equations. So what is an inverse operation and how do you use them? Well, we know that regular operations are things that put together our numbers and our variables with addition, subtraction, multiplication, and division. The inverse operations are the opposites of those. They are the operations that undo each other. So for example, the operation that undoes or is the inverse of addition would be subtraction. The operation that's the inverse of subtraction would be the opposite or addition. So they go together. Same idea is when I talk about multiplication, we would get division is the inverse. And the same idea that division is the inverse of multiplication. So it's important that we understand what an inverse is. It's the opposite of the other operation. And our operations for the moment are addition, subtraction, multiplying, and dividing. We will be adding some other operations throughout the year as we go. Some of them you may have seen in the past a little bit, but we'll definitely spend some more time with those as we go forward. So the second part of this question is, how do you use them? So let's start looking at some of these examples. So looking at example 1, here's where we want to see your steps. This might be a question that many of us could say, well, I could do that in my head, which is great, but we want to be able to see the steps. So here's how this works. We have x minus 7 equals negative 6. So we're trying to find the number that x has to be to make this equation work. Remember, an equation is equal value on both sides after everything is put together. So here's what we do. First, I want you to draw a line right through that equal sign to show the wall, the kind of boundary between the left side of the equation and the right side of the equation. Okay? Anytime we cross that line, we have to use the inverse operations to move things across. Okay? Secondly, what I want you to do is I want you to always get in the habit of circling the variable. This just starts to give us some notes. We know what we need to do to solve this. The variable is what we're trying to solve for, so we just put a circle around it. That way we know that that's the thing that we need to get by itself or isolate. So now we need to say, what is on the side with the x that we need to move? Well, you can very clearly see that the thing that's next to it is this right here, this minus 7. So remember what I said. If I want to move this 7 over to the other side, I have to cross over that line. So the only way I can move it is to do the inverse operation of what I see. So right now, we see minus 7. So what is the one that undoes minus or subtraction? Right. Addition will undo the subtraction. So what we do is we are now going to undo minus 7 with a plus 7. So if I'm subtracting 7, to move it, I need to do the opposite, which is to add 7. Now remember, with any equation, if I want to move something, I have to do the exact same thing to both sides. So if I added 7 to the left side, I also have to add 7 to the right side. Then I'm just going to go ahead now down here and I'm going to draw this line and now add. So x is still going to be there. X is going to come down. But then what is negative 7 right here plus 7? Well, that becomes 0. So it cancels, and that means it's gone off of the left side. That means that now I have the x all by itself, which is what we're looking for. And then I go to the other side and I say, well, I have a negative 6 plus 7. Remembering my integer rules from last year, negative 6 plus 7 is a positive 1. So I think this is my answer. How do I know it's my answer? Well, to know it's the answer, I go back to the original equation. X minus 7 equals negative 6. I'm going to put a little question mark here because we don't really know that that's right. I'm going to plug in the 1 for the x. So up above we said x equals 1. So 1 minus 7, does that equal negative 6? Well, if I look at my integer rules, 1 minus 7 does equal negative 6. That shows me that it works. And then I can come back up over here. Maybe I change the color a little bit. And I say, now I put a little box around this to say, there's my answer. The first equation is x equals 1. So I won't go through the others as detailed as that one, but that kind of shows you what we're expecting for work. Some of these we can do in our heads. I absolutely understand that. We do want to see the step to see how it gets there. And the great thing about equations, you can always plug in your answer and it should work if you have the right answer. So moving on to the next one, so letter B. So we have y plus 3.4 equals 0.5. So first thing I'm going to do is draw that line right through my equal sign. I am solving for y. Now I see plus 3.4. So I got to think to myself, what is the opposite of adding? Well, as we already talked about, adding and subtracting undo each other. So this time I'm now subtracting 3.4 to make that 3.4 on the left side move across the red line to the right side. And again, I have to do the exact same thing on both the left and the right. Then I can draw my line. 3.4 minus 3.4 cancels, so that disappears, leaving me with just the y. That's what we are looking for, so we're thinking we've got the answer now. And then I do 0.5 minus 3.4. Now remember, it's not 3.4 minus 0.5. It has to be 0.5 minus 3.4. And if I use my integer rules, I'm going to get negative 2.9. Now I won't show the check on this one because we just showed it in the last one. But to show the check, all I have to do is go back into my equation and say, plug in the y as a negative 2.9 and see if it works. Negative 2.9 plus 3.4, does it equal 0.5? If it does, I have the right answer. If it doesn't, I need to go back and figure out what went wrong. It does work. If I do negative 2.9 plus 3.4, I do get 0.5. Again, that's the great thing about equations. I now know that that's the right answer. Okay? Letter C. So letter C, 0.09W equals 1.8. So remember, when you have a number, the 0.09, right next to a variable w, what operation is that? That is multiplication. So when I see a number right in front of a variable, that means multiply, and that's important to remember. So again, just like we did on the previous ones, I want to draw this line right through the equal sign. I want to circle the thing that I'm solving for. I got to get everything away from the w. So this time, when I'm trying to move things from the w, I see 0.09 times w. So what do I need to think about to move the 0.09? Yes, division undoes multiplication. So for division, what we do is we use this bar. It's like a fraction bar, because really a fraction is division. And I'm going to divide both sides by 0.09 to move it from the left side over to the right side. Now, remember, like in A and B, we did the inverse and we got zeros to cancel out that number that moved. This time, 0.09 divided by 0.09 is not 0. Remember, it would be 1. But really, that's what we want. We want 1 W. So the W is all by itself. Now all I need to do is figure out, well, what's 1.8 divided by 0.09? 0.09. And if I use my calculator or my long division, which would be awesome, I get W equals 20. Now again, a quick check here. This is one that a lot of people might put down 2 right away because we see the 1, 8, and the 9, and we think 18 divided by 9 is 2. But this is actually a 20. So if you did just say it was 2, that's where a check is really valuable because it would show you right away that that's not the right answer. The right answer would be W equals 20. Now, do you remember how to inverse a fraction? Basically, what that is saying, and you probably will maybe recognize this after I write this part out, to inverse a fraction, basically what we're doing is multiplying, and I'm going to just abbreviate, multiply by the reciprocal. Okay? Now remember, what is a reciprocal? A reciprocal is when you take the numerator and denominator and switch them. So if it was in the numerator, when I do the reciprocal, that number is now in the denominator, and whatever was in the denominator is now in the numerator. So why does that matter? So this example D, what we're seeing again is another multiplication that we're going to have to use division to move it across. So looking at this problem, I'm going to draw my little line through the equal sign. We're solving for n. We're going to divide both sides by negative 3/4. So negative 3/4 divided by negative 3/4. Anything divided by itself is 1. So that's perfect. We get rid of that, leaving us with just the n. But now we have some work to do. So what is negative 2 divided by, I should put this division sign in there, divided by negative 3/4? So remember, when we do these, if I come back over here, and this is from the past, negative 2 divided by negative 3/4. Remember, when you're dividing two fractions, and negative 2 is a fraction, I could look at it as this, negative 2 over 1, that's the fraction of negative 2, divided by negative 3/4. So here's where that inverse comes in play. So to do this division of fractions, remember, you take the division sign and you change it to multiplication, and you flip over or do the reciprocal of the second number. So negative 3/4 becomes negative 4/3. It's still negative. You just take the numerator and flip it with the denominator. Now I just multiply those two fractions. So if I multiply two fractions, again remembering from the past, you can always just go straight across the numerator. Negative 2 times negative 4 is 8. And then you can go right across the denominator. Now I already used the negative signs for the 2 and the 4, so I won't use them again. I get 1 times 3 is 3. And I think I would rather see that as black. So with that in mind, I want to come back up top here. So we now have our answer. Doesn't want to move on me. I want to move. We have our answer. I'm just going to skip that for now. N equals 8/3. Now, one other thing I want to point to you as well. This year, I'm very happy with this answer, this improper fraction. And I know in the past, one of the things that you've always been taught to do is to turn these into things that would be mixed numbers. I am very happy with the improper fraction, 8/3, as long as we've taken out any common factors. In this case, 8 and 3 don't have any common factors to take out any further. So as long as the common factors are taken out, then we are good, and you can move on to the next one. So here we are on another example. So this one is a little bit different. We have a multiple choice question. We're trying to identify the solution of an equation. So the question is, what is the value of k that makes this equation work? Now, notice I put in this little blue division sign between the 4 and the 0.2. I apologize, but it didn't come through for some reason. But this equation is k plus 4 divided by 0.2 equals 5. Now, being multiple choice, there's lots of ways that you can do this. Certainly, you could go through each of the A, B, C, D answers, plug them in for k to see which one worked. That's certainly a strategy. But because we're trying to practice solving equations, let's just go with solving this. So like we just did on those other examples, let's draw a little line through the equal sign. That kind of shows us what we need to do to cross over the left side to the right side of our equation. So before we start moving things, we're solving for k. But notice that we've got a couple of other numbers there. On the previous examples, we only had one number to move. This time we got a couple, but I can combine those. Remember, if I think about my order of operations, or my GEMDAS, groupings, exponents, multiply and dividing. So multiply and dividing, hopefully right away tells you this someplace. This right here will come before AS, addition, subtraction. So I'm going to take care of the division first. So we're going to simplify this a little bit further. 4 divided by 0.2 is actually 20 to get to this equation. Now, I only have one thing to move to get k by itself. This is where I'm going to think, what is the opposite of plus 20? Well, it's minus 20. So if I take 5 and subtract 20, because these will cancel, 5 minus 20 is negative 15. That's my answer. I look over here, letter A is my answer, and again, to check it, I could plug that right back into that k up at the top. I would still be doing the division first, but I would have negative 15 plus 20 equals a negative 5, which is correct. So k equals negative 15. Now, on this last one, word problems. So lots of times word problems can cause trouble. So when we have a word problem, best thing to do is to go right through all the words, the sentences, to figure out what is that they're giving us and what is the things that we know, what is the thing that we're trying to answer. So the temperature in a crater on Mars is 0 degrees Celsius at 1 o'clock. The temperature decreases, which means it goes down 8 degrees Celsius every hour. So we want to keep that in mind. Every hour it's going down 8 degrees Celsius. When will the temperature be negative 50 degrees Celsius? Now, there's a couple ways you could do this. You could certainly make a chart and just start kind of writing down, after the 1 hour it goes this, after 1 hour it drops this, all the way down to the very, very bottom. I think that would just take a lot of time, and I think we can do this a lot faster. So here's a verbal model that we just looked at. So if the temperature change in Celsius, it's going to equal the hourly change, how much per hour it's changing, times the number of hours. So to follow this further, we have the change in temperature we're looking for is negative 50. We want to know when will the temperature be at negative 50. Because right now it's at 0. So the change in temperature would be 50 degrees. So the hourly change comes back to this decreases 8 degrees Celsius every hour. So that means it's going down 8 degrees per each hour. And the question is, how long until it gets to the negative 50? Well, that's the thing we don't know. We don't know how many hours. But if I take the negative 8 and multiply it by the number of hours, we want to be able to use that to see what it's going to take until we get to the negative 50 in our change. Okay, and remember the change in temperature, it's not that we want the temperature to be negative 50, so that's why that number goes there. It's because we went from 0 to negative 50 to see the change going down 50. It just happened to be we started at 0, so that negative 50 is still the same number. But now once we have the equation, we can just do what we did on the other equation, on the other ones. So again, we have our little line that goes through the middle of the equation. We're solving for this t that's right here. Now I see multiplication. So we're seeing a multiplication on this side, negative 8 times t. So that tells me to do division. So I'm going to divide both sides. It's the negative 8 that we're trying to move. So we divide both sides. Negative 8 divided by negative 8 is 1, leaving me with just the t. Negative 50 divided by negative 8 is 6.25. So is that our answer? Well, it is not. 6.25, remember in time, our clock goes in 60 minutes. In decimals, that 0.25 is out of 100. So really, let's think about this. This 6.25 represents 6 hours and not 25 minutes, but if you think about 25 as the quarter, it's a quarter of the next hour, so it's 15 minutes because on our clock, a quarter of an hour is 15. So if it is 0 at 1 o'clock, the question says, when will the temperature be at negative 50? So now we want to give our answer. It'll be negative 50 degrees Celsius at 1 o'clock it's 0, 6 hours and 15 minutes later, it will be 7:15 p.m. when our temperature is negative 50 degrees Celsius. So hopefully this is not too bad. Just remember you're looking for the operations to decide if I'm going over the equal sign. I have to use the opposite operations to actually move things over. Draw that line through the equal sign so you can actually see that things have to go across it. That would tell you you need to use the inverse. Addition goes with subtraction. Multiplication goes with division. So do the best you can with it. Make sure you're asking questions when we have our opportunities, and we will see you guys soon.